Friends, in the continuation of data science interview question answer series, we are moving to question difference between convolutional network CNN or recurrent neural network RNN. Primary use case CNN is spatial data, example images, grid, volume data. RNN sequential data, example text, time series, speech. Key operation CNN convolutional operation using trainable filter kernels to extract local features. RNN recurrence relevant relation, a loop that passes information from one step to the next. Weight sharing. In CNN, weight filters are shared across the spatial extent of the input, example across all location in an image. In RNN, weights are shared across time used for every steps in sequence. State memory. In CNN, no internal state or memory across different input images. RNN maintain an internal hidden state or memory that captures information from previous steps. Handling sequence length. CNN not designed for sequences. Input size is usually fixed. RNN can handle variable length sequences because the operation is required. Key advantage. CNN excellent at local feature extraction and learning hierarchical spatial pattern. RNN excellent at modeling temporal dependencies and sequential context. Common architecture CNN, LNet, LXNet, VGG, ResNet, Inception, RNN, simple RNN, LSTM, long short-term memory, GRU, gated recurrent unit, problem mitigation. In CNN deals with curse of dimensionality in image data via pooling and weight sharing. RNN deals with vanishing exploding gradients problem via LSTM and GRU. Moving to question difference between batch normalization and layer normalization. Normalization axis. Normalization feature across the batch dimension for a single feature. In LN, normalize feature across the feature dimension for single sample calculation. In batch normalization, use the mean and variance calculate across all samples in current mini batch. Layer normalization uses the mean and variance calculated across all features within a single training sample dependency. Batch normalization depend on the mini batch size. Performance degrades with very small batches. Layer normalization independent of batch size performs consistently regardless of batch size suitability. Batch normalization most effective in standard feed forward or convolutional layer, example computer vision. In layer normalization most effective in recurrent neural network RNN and transformers, example NLP. Inference deployment. Batch normalization requires tracking and using running means and variance calculated during training. In layer normalization does not require running statistic. The calculation is self-contained within the sample. Computational overhead. Batch normalization adds slightly overhead requires two passes mean variance calculation and normalization. Layer normalization adds slightly overhead but often simpler to implement and deploy in recurrent steps. Statistical property. Batch normalization normalizes the input to neurons so it has a zero mean and unit variance across the batch. Layer normalization normalizes the hidden state vector within one layer so it has a zero mean and unit variance. Use case example. Batch normalization used widely in CNN architecture like ResNet. Layer normalization used widely in transformer architecture like BERT and GPT. Moving to question, difference between cross-validation and bootstrap uh, king primary goal. Cross-validation to estimate the generalization error model performance on unseen data and true hyper parameters. Bootstrapping to estimate the sampling distribution of a statics, example mean, median, variance, or model parameter. Data uses. Cross-validation splits the original data into non-overlapping training and validation set. Bootstrapping creates new data set by sampling with replacement from original data. Training set. Cross-validation creates K training sets in K folds where each of 1 to 1 per K of the original data. Bootstrapping create a B bootstrap samples each the same size as original but with duplicates and missing points. Dataset overlap. Cross validation cross-validation training and validation sets are mutually exclusive. No sample overlap between folds. Bootstrap samples are highly overlapping, approx 63.2% unique samples in each. Purpose in ML model evaluation, hyperparameter tuning, grid search, etc. Model selection, bootstrapping estimating the uncertainty confidence interval of model prediction or statistical measures. Bias variance trade-off in cross validation generally has lower bias than a single train set split. Bootstrapping can lead bias estimates if statics itself is biased. Example, bias bootstrapper uh, nearly equal to bias original. Common variant cross-validation k-fold CV. Cross-validation leave out one cross-validation, stratified cross-validation. In bootstrapping, simple bootstrap, 632 bootstrap, smoothed bootstrap. Real world example, cross validation, choosing the optimal lambda in lasso regression, bootstrapping, estimating the confidence interval for the R2 of a linear regression model. Please like, subscribe and share the channel. Thank you.